Hey, welcome. So today, we're going to dive into a concept in AI that kind of flips the whole script. Forget about that classic idea of one giant, all-knowing superbrain, because the future of AI, it might just look a lot more like a team.
Right? This is the big idea behind something called multi-agent systems. And in this explainer, we are going to break down exactly how these AI teams work, how they're being used to build literally everything from smarter customer service to entire software apps, and most importantly, how you can start thinking about them. Okay, so before we can even talk about the team, we got to understand the individual player, right? The autonomous agent. This is the fundamental building block for everything else we're going to cover. So what really makes an agent different from, say, just a chatbot?
So here's the deal. It's really easy to hear the word agent and just think, oh, a chatbot. But they are worlds apart. An agent is a proactive decision maker. It doesn't just sit there waiting for your command. It actually perceives its world, it thinks for itself, and it takes action to hit a goal.
Let's make this really clear. A chatbot is reactive. You ask, what's the weather? It tells you the forecast. End of story. An agent, though, is proactive. It sees that same rainy forecast, it checks your calendar, and it automatically reschedules the outdoor meeting it knows you have planned. It didn't wait to be asked. That right there is autonomy in action.
So how in the world does an agent pull this off? Well, it really boils down to three core parts. First, reasoning. It uses a large language model and a process, something like chain of thought, to think step by step through a problem. Second is memory. It's got short-term memory for what it's doing right now, and long-term memory, usually a vector database, to remember stuff from the past. And third, and this is the game changer, tools. This is its ability to use external APIs and run code. It's what lets it actually do things in the world, not just think about them.
Okay, so one agent is pretty powerful, but what happens when a task is just too big or too complex for one specialist? Well, it's just like a human team, right? You bring in more experts, and this is exactly where we go from a single agent to a multi-agent system.
So you might be wondering, why not just build one giant super agent to do everything? Well, for the same reason, a company hires a whole team instead of just one genius. A team gives you specialization. Each agent is an expert in its little area, which means you get way higher quality work. And you get parallelism. They can all work at the same time, which is obviously a lot faster. But yeah, there are costs. You've got all this coordination overhead, and every single message they send back and forth costs API credits or tokens. That can get expensive, fast.
And this really is the absolute heart of it. The magic here isn't just throwing a bunch of agents at a problem. It's all about how they coordinate. Getting them to work together like a well-oiled machine, that's what unlocks the real power here. And that brings us to maybe the most important part of any multi-agent system, orchestration.
Think of orchestration as the playbook for your AI team. It's the set of rules, the communication flows, it's the glue that holds everything together. And make sure they aren't just a chaotic mob of bots, but a real, cohesive unit working towards one big goal.
So, broadly speaking, there are three main patterns for how these agents can team up. The simplest is sequential, which is basically an assembly line. Agent 1 does its job, passes the result to Agent 2, and so on. The most common is probably hierarchical. This is like your typical company structure. A manager agent delegates tasks to a bunch of specialized worker agents. And then there's the really wild one, the swarm. Here, the agents self-organize without any central leader. It can lead to some surprisingly creative emergent solutions. And believe me, choosing the right pattern for your task is one of the biggest design decisions you're going to make.
All right, this all sounds great in theory, but how do you actually build these things? And maybe more importantly, how do you safely manage them in the real world? Let's get practical.
The good news is you're not starting from scratch. There are some amazing open source frameworks that give you the foundation. Crew AI, for example, is fantastic for defining specific roles, like a researcher agent and a writer agent. AutoGen is built for agents that solve problems by talking to each other. And then LangGraph lets you build really complex, multi-step workflows with a ton of control. With these tools, your job actually shifts from being just a coder to being more of an architect. You're designing and managing the AI team itself.
Now listen up, because this is what separates a cool demo from a reliable, production-ready system. It's all about governance. You absolutely need guardrails. These are hard rules an agent cannot break, like a spending limit. You need monitoring so you can see what your agents are actually doing, how many tokens they're burning through and where they're failing. And for any high-stakes decision, you need a human in the loop to give that final yes or no. I'm telling you, this stuff is completely non-negotiable for any real-world deployment.
So let's just do a quick recap. It all starts with this single agent and its core abilities: reasoning, memory, and tools.
We build these agents into teams, these multi-agent systems, to get the power of specialization and parallelism. Then we coordinate them using orchestration patterns, like sequential, hierarchical, or swarm. And finally, and this is so important, we make them safe and reliable for the real world through solid governance, setting guardrails, monitoring their work, and always keeping a human in the loop.
So the question is no longer if you'll be working with these systems, it's really a question of when. I mean, this isn't sci-fi anymore. This is the next phase of automation, the next phase of software development. So the real takeaway here is to start thinking less like a user of AI and more like a manager of a very talented, very fast, and very autonomous team.
Hey, if you found this breakdown of multi-agent systems useful, do me a favor and subscribe for more explainers where we cut through the hype and get right to the core of how this stuff actually works. Thanks for watching, and we'll see you in the next one.